Hey everybody, this is just going to be a short video wrapping up one more idea from chapter 7, and that idea is type 1 and type 2 error. Okay, so the basic idea is a hypothesis test can either reject the null hypothesis because there is strong evidence that the null hypothesis probably is wrong, or it can fail to reject the null hypothesis because there is a lack of evidence that would disprove the null hypothesis. But remember that rejecting the null hypothesis is based on a probability. It is very unlikely that I would have observed the data I saw if the null hypothesis were true. Therefore, I think the null hypothesis is false. Although it's very unlikely, there's still a chance that I could have observed this data, even with the null hypothesis being true. So type 1 error is rejecting the null hypothesis based on your data, even though the null hypothesis is in fact true. Let me give you an example. Our null hypothesis is eggs are the average egg weight is 50 grams. Our alternative hypothesis is the average egg weight is more than 50 grams. We choose a significance level equals 0.05. This means that if my sample were to occur less than 5% of the time, assuming the null hypothesis is true, I will reject the null hypothesis. Well, this means that even when the null hypothesis is true, 5% of the time, I will reject the null hypothesis. Because that is how often my data would have a p-value. Remember, that means the probability of observing it, less than 5%. Type 1 error would come about if I randomly got an extreme sample from the 50-gram distribution and rejected the null hypothesis because of that. The probability of type 1 error is exactly equal to the significance level. Another word for type 1 error is false positive. That is, my sample seemed like strong positive evidence for rejecting the null hypothesis, but my sample actually still fits the null hypothesis. It just is perhaps, it just is unlikely. How to reduce type 1 error? There's two ways, or generally three ways. The first way is the way we always improve our statistics: increase the sample size. This will make it less likely that your sample is randomly appears not to fit the null hypothesis when it in fact does. The second way is to decrease the significance level. If I choose a smaller significance level, like 0.01, it is less likely that my data will give me a p-value below that significance level, which means it is less likely to incorrectly reject the null hypothesis. And the third way to reduce type 1 error is to repeat the experiment. If I were to take, let's see, 20 different samples of 30 eggs, and each of those samples gave me a p-value below the significance level, then it is basically guaranteed, as close as you can get in statistics, that the null hypothesis is false. Getting below the significance level randomly once, it can happen. Getting below the significance level randomly 20 times, you would not expect that to happen. Type 2 error is when you fail to reject the null hypothesis, even though the null hypothesis is false and should be rejected. So my example with the 50 eggs, H naught is mean egg weight is 50 grams. HA is mean weight is more than 50 grams. Suppose, in fact, the mean weight of an egg is 55 grams, but my sample has a mean weight of 51 grams, and the p-value is above the significance level. I will fail to reject the null hypothesis, even though the null hypothesis is false. Another name for type 2 error is a false negative. It seems like my data is not strong enough to reject the null hypothesis. My hypothesis test gives me a negative result, even though the null hypothesis is in fact false. A common example of that is in diagnostic testing for, let's say, elevated cholesterol. It is possible that a person's blood work comes back in the green zone when actually their cholesterol is concerning. The diagnostic test would return negative or high cholesterol when in fact their cholesterol is high. Every diagnostic test has a certain expected rate of false positives and false negatives. And so if you are going into the medical field, this is actually one of the most important ideas from this statistics class. Is you need to be aware when you conduct a diagnostic test and you get a result, there is a chance that that result is wrong. Every time a diagnostic test is conducted, there is a chance that the result is wrong, either a false positive or a false negative. So as a medical professional, you need to be able to make judgment calls about when not to trust the results of a test. So ways to reduce the chance of type 2 error. It's basically the same. Increase your sample size. That will reduce your chance of type 2 error. If you increase the significance level, say to 0.1 instead of 0.05, this will make it more likely that your data leads you to reject the null hypothesis, reducing the chance of failing to reject a false null hypothesis. However, there's some tension here because if you increase the significance level, you reduce type 2 error, the chance of type 2 error, but you increase the chance of type 1 error, I should say the chance. And so again, you have to make a judgment call. And the third is conduct more tests, just like with the reducing the chance of the type 2 error. If you fail to reject the null hypothesis multiple times, that can raise your confidence that you are not falsely, that you don't have a false negative. Right, so that's type 2 error. Type 1 and type 2 error are always exist in a hypothesis test. Over time, the choice of using a significance level of 0.05 has become the standard because it balances the probability of type 1 and type 2 error. And rather than changing the significance level, it's just recommended to increase your sample size as the first step, and as a second step, to repeat experiments. That concludes this video, and check back next week for videos on our final chapter, Chapter 8.